Most of our experiments, we just pour lava over a dry sand surface. Now we do this just so we have a uniform sort of behavior, and we don't see any sort of behavior by the lava that just reflects the nature of that surface. In other cases, we want to do experiments where we specifically want to see how the surface affects the lava, the way it flows and the way the lava flow looks at the end of the experiment. So here we also see places where we poured the lava over wet sand. When we pour it over the wet sand, the water in the sand is vaporized and it kind of does natural glass blowing. The water vapor expands rapidly and sort of blows balloons of lava that are called limu opale. And you can see some of those in these pictures. In other cases, we pour the lava over ice. We do this because we want to understand how lava flows interact with glacial ice in Iceland, for example, where we do some of our research, and also how lava might interact with ice on top of large volcanoes where there's ice caps commonly found. Here we can see that as the lava flows out over the ice, it blows more of those limu, those beautiful bubbles that burst as water vapor is created. And it's a very dynamic surface. In fact, on some of the steeper ice surfaces, we even see hydroplaning, where water vapor is trapped underneath the lava and allows it to slide down the slope very, very rapidly. In the final type of experiment that we do, we pour lava directly into water. And that happens, of course, in places like Hawaii, where lava runs down slope and into the ocean and makes very explosive steam eruptions. But it also happens on the bottom of the ocean, along mid-ocean ridge spreading centers. In fact, that's where most of the lava on our planet is erupted. We would like to understand how lava affects those lava flows as they form underwater. So in this case, we made a J-shaped tube to pour the lava so it comes out underneath the water in the tank. As it does so, it makes these lumpy flows that are very similar to the pillow lavas that we see on the bottom of the ocean.